Welcome to Lesson 09, the one where storage stops being scary. Back in Lesson 01, we set up LVM at install time, and in Lesson 04, we ran a quick LVX10 plus 10 gig on Torach VRR. Today we go deep, the mental model of physical volumes, volume groups, and logical volumes, then online resize, snapshots in 50 milliseconds, thin provisioning, RAID, and live migration with PV move. By the end, you'll be fluent and ready for the backup lesson in L18. Start with the mental model. Everything else hangs off this. LVM is a layer cake. Physical volumes wrap your raw disks, volume groups pool those PVs into one big bucket of storage, and logical volumes carve name slices out of that bucket. Root, var, home, swap. The file system sits on top of the LV. Run pvas, VGs, and LVs to inspect each layer, or sudo lsblk to see the whole tree at once. Disk, partition, LVM, mount point. Notice VG0 already has 2 PVs, 4 LVs, and 210 gigs free to play with. Now the runbook, a new disk shows up as shush dev shsdb, and 5 commands turn it into mounted storage. Inspect with lsblk, wipe hefs any old signatures, then pv create wraps the raw disk as a physical volume. No partition table needed. Next, VGX10 folds it into VG0's existing pool, or VG create spins up a separate VG if you want an isolated failure domain. Then LV create carves out the slice, mkf.xt4 formats it, mount brings it live, and call back to lesson 4, persist it in fstab by UID and run mount A to validate before any reboot bites you. And this is the operation you'll run more than any other in production. Pager fires, yours var at 80%, the alert we set up back in lesson 4, check V free on the VG, then 2 commands, lvx10-l plus 10 gig, then resize 2fs, or xfs ash growths if it's xfs. File system grows live, no unmount, no reboot, problem gone in about 2 seconds. The pro move is the -r flag on LVX10, which resizes the file system in the same call. Shrinking? Technically possible on XT4, but unmount required and risky. Rule of thumb, grow LVs to fit data, never the other way around. Now here's where LVM stops feeling like a storage tool and starts feeling like a time machine. A snapshot is a copy-on-write view of an LV frozen at a moment in time. 50 milliseconds to create, regardless of whether the volume is 5 gig or 5 terabyte. The classic pattern is right there in the middle. Stop Postgres for 3 seconds, snapshot, restart. Now you've got a consistent point-in-time copy you can back up at leisure while the database serves traffic. And the merge command at the bottom? That's a full rollback. Undo every change since the snapshot in one command. The catch is sizing. That -L reserve has to hold every block that changes during the snapshot's lifetime. Busy database, budget 20 to 30%. Quiet var 5 to 10. Run out of space and the snapshot drops itself, silently. Speaking of running out of space, thin provisioning takes that risk and turns it into a strategy. The idea is delicious. You hand out 100 gigs each to Web 1, Web 2, and Web 3, committing 300 gigabytes on a pool that physically holds 100. It works because most workloads only touch 10 to 20% of what they claim. The pool is your real reservoir. The thin LVs just sip from it as they actually write. But notice that red warning. If the pool fills, every thin LV on it starts failing writes simultaneously. So you do 2 things. Configure auto-extend in lvm.conf at 75%, and wire up a Prometheus alert on data % above 80. We'll build that alert in lesson 19. No monitoring means silent corruption, not a maybe, a when. Now disks fail. 2 a year across any decent fleet is just arithmetic. The good news, LVM speaks RAID natively, so you don't bolt MDADM underneath and manage 2 stacks. Same LV create, just add, type RAID 1 and M1, and you've got a mirrored 50 gig volume across 2 PVs. Check health with LVs and copy %. 100 means fully synced. When a disk dies, LV convert, repair drops the bad leg, and the LV keeps serving. Swap the hardware, PV create, VG extend, then LV convert back to RAID 1, and the resync runs itself. Pick RAID 1 for anything that hurts to lose, RAID 5 or 6 when you need capacity with tolerance, RAID 0 only when the data is genuinely replaceable. Mirroring protects you from sudden death, but disks usually warn you first. Smart throws errors, or you simply want to move to faster NVMe. That's where PV Movie earns its keep. You PV create the new disk, VD extend it into the same VG so the group temporarily owns both, then PV move the old PV to the new one. Extends copy across while the file system stays mounted and apps keep serving. When it hits 100%, vGreduce and PVR remove the old disk and pull it out. If a reboot interrupts the copy, just run PV move with no arguments and it resumes. Slow on big disks, budget an hour or two per terabyte, but completely safe. And frankly, no other Linux storage layer does this live. So we've covered the tools. Now the harder question, which one, when? This matrix is the cheat sheet that eventually lives in your head. File system running low? LVextend with -R. Consistent database dump, snapshot, then tar from the snapshot. Failing disk? PV move. Risky upgrade you might roll back? Snapshot plus LV convert merge. Need to survive a disk death? RAID 1. Overcommitting to tenants? Thin pool. And the one that trips people up, moving to a different VG. PV move can't cross volume groups, so you snapshot in rsync. One rule above all, snapshots are not backups. They live on the same disk. Real backups go to another host, and that's lesson 18. Now the scar tissue, 5 LVM mistakes that have bitten real engineers, probably more than once. Number 1, undersizing a snapshot. A 1 gig reservation on a busy 100 gig volume fills in hours, the snapshot goes inactive, and your backup tar is silently corrupt. 2, forgetting resize 2Fs after LVextend. That's why -R exists. 3, thin pool overcommit with no auto-extend, and 10 LVs go read only at once. 4, vGreduce -- force when extends still live on the disk. Instant data loss. Always PV move first. And 5, a RAID 1 leg fails silently. Nobody's watching LV your health hash status. Then the second disk dies. Monitor everything. So let's land this. 6 skills you now own. The layer cake. PV wraps the disk. VG is the pool. LV is the name slice. File system on top. You can build it from scratch, resize it live in 2 seconds, snapshot a running database for a clean backup, overcommit safely with thin pools, and mirror the critical stuff with RAID 1, and migrate to a new disk with PV move while everything stays mounted. Storage stopped being scary. Next lesson, lesson 10, cron and system timers. Scheduling the backups, the log rotations, the certbot renewals, all of it. That's lesson 9 in the bag. LVM is unlocked. Mental model, online resize, snapshots, thin pools, RAID, PV move, all of it production ready. Next up, lesson 10, cron and system timers. We'll cover classic cron tab syntax, on calendar and system units, randomized delay sec to dodge the thundering herd across a fleet, and persistent for missed runs. Type next lesson, and I'll see you there.